guys, let's just check the sound. All right, we're good to go. So if any of the other year 12s or 11s are joining in, I do apologize. I've not been the best in the last kind of 4 days. But anyway, what we got to do, we got to do. So what I've got today, some of the questions is, by the way, can you guys actually hear me? I know chat is very quiet at the moment. Okay, no, that's good. One yes is always good to go. Angie, I still got your questions in my head. Don't worry about it. I'll go through them. So we got a whole lot of questions that got sent through to me, which I know probably most people will be looking at. The questions you sent me, Angie, are like next level. So I might just send it, do the working just separately and just send it to you. All right. So what we've got today is we've got some complex numbers. I've got a differentiation question with parametrics, another differentiation question. This one is integration. Got another differentiation and a differentiation and a differentiation. So what I said to you guys is this, if you do have any questions that you want to add on to this, as long as it's not like questions that I've done before, then feel free to send it. I know, for example, someone asked for 2016 2E differentiation, so we'll actually end up doing that. All right, so I'm kind of getting rid of this first complex number question. I've got a variety of mix of questions here, so you just gotta bear with me, guys. So with this question here, what we've got is, yeah, good luck with that, Lucas. So what we got is we've got Z, and we're also being told that argument of Z is pi over 4. Now just remember that pi over 4 is 45 degrees, and usually that actually means that the real part equals to the imaginary part. All right, so all you have to do really is this complex number here, we just need to write it up so that you get the real part and imaginary part, and then you are pretty much good to go there. So what we're going to do is we're going to kind of rationalize the denominator. So we've got 1 plus 3i times p plus qi multiplied. Now the conjugate of this is p minus qi and p minus qi. So when we multiply the numerator, we're going to get p plus 3ip minus qi, and then plus, minus 3qi squared, and the whole thing is divided by p squared minus q squared I squared. Alright, so next thing is getting rid of the I squareds. So remember that I squared is equal to -1, and because of that we're going to rewrite this as p plus 3ip minus qi, and we've got minus 3q times -1 divided by p squared minus q squared times -1. Now this part is really important, because whenever you get a question like this, just rationalize the denominator and start rearranging, and things just magically start kind of falling into place. So in this case, what we've got is we've got p plus 3q plus 3ip minus qi. Now if you wondered how I got the plus 3q, that's basically this here. And that's all divided by p squared plus q squared. So at this point we can kind of start separating the real and the imaginary parts, because in the real parts you've got p plus 3q and the imaginary part is 3p minus q, and the whole thing is divided by p squared plus q squared. So here's the thing. Remember that I talked to you earlier about how real is equal to imaginary when it's pi over 4. Alright, so when the argument is pi over 4, that's 45 degrees, which means we can actually say that the real part, which is p plus 3q, is going to equal the imaginary part, which is 3p minus q. So I'm going to go right back to the top of the question there. So proof was prove that p minus 2q is equal to 0. So because real equals imaginary, all we have to do is p plus 3q equals 3p minus q. Rearrange this and you're going to get p minus 3p plus 3q plus q equals to 0. You got negative 2p plus 4q equals to 0. Take out the common factor of negative 2. You get p minus 2q equals 0. Get rid of the negative 2 to the other side, which means you get p minus 2q equals 0. Dylan, the next one is probably going to be not tomorrow, the day after tomorrow. Kenny, I think you asked me that before and I forgot to message you. Yes, you are allowed to use a graphics calculator to solve simultaneous equations in level 2 algebra. Alright, Salty, I'll just need to put that towards the end of my list because I got a huge list of questions that I need to work through. So one other thing I wanted to tell you guys is this, while you are here. I mean, I've not seen this happen before, but on the odd occasion, they might actually not use pi over 4. They might use something like argument is pi over 3 or pi over 6. So if they do that, so just to give you a bit of an idea of what happens when they have argument is equal to pi over 3 or pi over 6. Now in your, I'm going to see if I can try and go to my, so in your formula sheet, what they give you is, they actually give you guys the special triangles. So if you guys have a look at this. So I'm looking at the pi over 3, which is there. So I'm just going to quickly copy that diagram. 1 and root 3, and then I'm going to copy the pi over 6 one, which is root 3 and 1. So on the odd occasion, if they do give you this, where the argument is pi over 3 or pi over 6, then you just need to remember that 1 real equals square root of 3 imaginary. So when they say argument is equal to pi over 4, that's when you have 1 and 1. So that's why you go real equals imaginary. But when they do argument of pi over 3, just got to go 1 times real, sorry, 1 of real is square root of 3 times imaginary. And likewise, you can actually do square root of 3 times real equals imaginary if it's pi over 6. Rukun, you're absolutely right there. Yeah, so it's basically if you are given one of the roots, then the conjugate will always be a complex root. All right, so let us go to the next question, which is differentiation 1. And this question here, I kind of just kind of smashed it through really quickly. But basically, they were asked to find the double differentiation of this for parametric equation. All I'm going to tell you guys is this: like, see, whenever you see parametric equations, just go back to the formula sheet. Okay, in the formula sheet, they do give you guys the main equation that you're going to need here. So the parametric functions thing is actually given, and this part is really important because all it is just learning how to substitute things and a little bit of differentiation that actually happens to it. So I'm going to copy down those two formulas. So dy dx is dy dt times dt over dx, and then the second differentiation of it is the differentiation of dy dx with respect to dt multiplied by dt dx. All right, so let me just go back to my main screen there. I was just talking to myself. So all I've done is I've just copied down those two formulas, right? So the first thing I'm going to do is dx dt. So dx dt is equal to 4 cos t. Then I'm going to do dy dt. So dy dt is equal to 5 negative sine t, which means now I'm going to use this formula here to work out dy dx. So dy dx is equal to dy dt times dt dx. So I'm going to get negative 5 sine t times 1 over 4 cos t. So once we have that, we're going to rewrite this as negative 5 sine t over 4 cos t. Now I'm going to be honest with you guys, like a lot of people see this and then they go, oh, I'm going to use quotient rule for this. Just remember that if you go into your formula sheet, you will be given, can't remember, do you actually get given the sine over cos? Let me have a look. That's okay, so they don't actually give you that, but that's all right. That's just something that you just need to remember. So what I mean by that is that when you have, see how you got cot theta is cos theta over sine theta? So remember that sine theta over cos theta is actually equal to tan theta. So what we're going to do is we're going to rewrite this as minus 1.25 tan of t. So now that we've got that, we've actually got to differentiate this with respect to t. So basically what I'm trying to do is I'm trying to do this part here, which means I need to differentiate this with respect to t. So if I was to do that, so d of dy dx dt, the differentiation of that is going to be negative 1.25, and then tan t, when I differentiate it, I'm going to get sec squared t. I can't remember now. You always forget anything beyond tan. Tan is sec squared t. Yeah, that's the one. So what we have is we're going to rewrite this now as negative 1.25 sec squared t multiplied by dt dx, which was 1 over 4 cos t. And I believe that's basically it. Now cos over sine is cot theta. All right. So are we okay with this question? So this was actually a double differentiation question. Some on the odd occasion I've seen it pop up as an E question, which is but then they don't keep it as clean as with sine and cos. They try and kind of make things a little bit difficult for you guys. All right, kind of moving on. Next question. FBI, yes, cos over sine is given, but sine over cos is not given. Cool. We go to this one here. So, with this question here, well, we got a standard find the area of the rectangle kind of question here. All right. So what we're going to do is we're going to kind of put the height and base and height of the rectangle. So remember that the distance from here to here is x, which means the distance going the other side is also going to be x. So the base is going to be 2x. And as for the height, need a different colored pen. Is that's going to be the y value itself. So it's going to be e to the power of negative x squared. So what we've got here is we've actually got area equals base times height. So area is equal to 2x multiplied by e of negative x squared. Okay, so once we get that, what we need to do is work out area. Well, we just got to differentiate the area and put it equal to 0. So, so we're going to put this as u. What are we going to do? We're going to put this as u and v. And in this case, we're going to use product rule. So you've got u equals to 2x, which means u dash equals to 2. V equals e to the power of negative x squared. V dash equals negative 2x e to the power of negative x squared. So once we do this, we have our area dash, which is u dash v plus uv dash. So we're going to get 2 times e to the power of negative x squared plus 2x times negative 2x times e to the power of negative x squared. So once we get this, remember that we've got to put a dash equals to 0. So we're going to put this equal to 0 because that's when maximum or minimum happens. So at this point, I'm going to take out e of negative x squared as a common factor. And what I'm left with is 2 plus negative 4x. Okay, so just in case you missed that, I've got e of negative x squared as a common factor, so I'm actually taking it out, and I'm left with 2 plus negative 4x. Yeah, Ramesh, I'm still not well, and I've got a 7-hour parent-teacher meeting tomorrow, so that's going to be fun. Cool. So why not? Well, actually, yeah, you're right. My bad. That was my mistake. There we go. Minus 4x squared. Thank you for that. Cool. So once we get this, at this point, we can actually say e of negative x squared is equal to 0, or 2 minus 4x squared is equal to 0. All right. Now in this case, not possible, so we're going to kind of ignore it completely. And in this case, we're going to get 4x squared is equal to 2, x squared is equal to a half. Therefore, we can say that x is equal to plus or minus square root of half. Now, here's the thing. Going back to the question actually says find the coordinate of C. All right. So we've actually got to write down the value of C. So C is going to be positive square root of half, and the y value is e to the power of negative x squared. So we just got to do that here quickly. So we're going to go e to the power of square root of half squared, so which means we're going to get e to the power of negative half as the value. So our coordinate for C equals square root of half, and don't know what this is, get out of here, and e to the power of negative half. Now, you do not need to write these as decimal points. You can actually just leave it in E format. It's absolutely fine. Yes, Rukan, it will be loaded up on the channel. Nah, you don't need to, Bernice. You can just leave it as like that. Trishika, you can't actually have e to the power of anything equals to 0. So let me show you what I mean by Desmos.com. So when you actually have a exponential curve, right? So when you have an exponential curve, it is e to the power of x. So notice how when you have e to the power of x, it can't actually, the y value can't actually be 0. So yeah, it's just not possible. So even if I put it as negative x squared, what's going to happen is there's going to be an asymptote at 0. So that value is, it's never going to touch that value no matter how much I kind of zoom in there. So that's why we kind of say it's not actually possible. All right, so let's go to the next question. You know, it's a pity because I think this is only like the first couple of integration questions that I've actually done. I don't know why people are obsessed with differentiation, but anyway, I'm gonna go through this particular one and the sugar syrup one. Now, I might stuff this up, there's a good chance, and I do apologize about that. But the nice thing is they've actually given us the equation, and so it's just a matter of just rearranging things. So, what we know about this particular question is after a minute, okay, so after a minute, okay, fine. So A is you've got to try and prove the differential equation, right? So whenever you see a differential equation, all you really got to do is swap things around. Like bring, and I hate when they do this. Like in this question, what they've done is they've actually put x in here, and I kid you not, the number of times I've actually seen kids do this. They do this 500k minus xk, and then they start integrating x. So really important to remember this part, okay? When it actually says dx dt, dx over dt, that means when you integrate it, the function should look like this, where x is going to be on the left hand side and t is going to be on the right hand side. Okay, so it's really important that you guys recognize that, because they keep doing this where they put x on the left hand side just to trick you a little bit almost. So in this case, what I've got here is k 500 minus x. So I'm going to bring it across. I'm going to bring it as dx over 500 minus x equals k dt. And once you do this, then what you can do is ln of 500 minus x divided by -1 equals kt plus c. So at this point, I'm going to get rid of the -1. So I'm just going to write this as ln of 500 minus x equals negative kt plus c. Now, you might wonder why I haven't put plus c and put it as negative c. Just remember that c is a constant, so it doesn't really matter. I can just still leave it as a constant because I don't know what that number is. So therefore, I don't have to stress too much about changing the sign of c and everything like that. So the next step is I'm going to put it as 500 minus x equals e to the power of negative kt plus c. And also, e to the power of c could be separated like this. So I'm going to put this as 500 minus x, and because e to the power of a constant, sure, Benny, which step are we talking about? Let me just put some numbers here. Benny's, I think that was a question, man, right at the top. Like, they actually gave us the question and then they asked us to prove to get to x equals 500 minus 500 ekt. Oh, no. Ramesh, we're dividing it by -1 is because whenever you do integration, you've got to divide by whatever's the differentiation of whatever's inside the bracket. So for example, if I have like 1 over 3x, when I integrate this, I'm going to get ln of 3x, and then that's going to get divided by the differentiation of whatever's inside this bracket, which happens to be 3. That's where that -1 came from, because when I differentiated 500 minus x, I get -1. Cool. So, going back to step 5, we've got e of c. So what I can do is I can actually replace e of c as like another letter, a for example in this case, and I'm going to put it as e of negative kt. Now I still haven't kind of got anywhere near to this equation that they asked me to get to. So if I go back to the question, we actually need to know what is x. And if you have a look at it, x is the grams that has been dissolved at any time t seconds. So we can safely assume that when t is equal to 0, that no sugar has actually been dissolved. So at t equals to 0, we can say that x is equal to 0. And we actually get that information from this highlighted part where t equals to 0 and x equals to 0. So we're going to go back in here and we're going to substitute when t is equal to 0, x is equal to 0. So 500 minus 0 equals ae negative k times 0. And so what we're going to get is a is equal to 500. So once we get that, we now can actually write our equation, because we're going to get 500 minus x equals 500 e of negative kt. And if we rearrange this, we're going to get x is equal to 500 minus 500 e negative kt. And I believe that's what the question actually said at the top there. So this process that I actually did right now, this 10-step process or whatever steps I took to do this, is really important that you guys actually show this working, because I've noticed that the differential equation questions, they've almost, it's like they've just made them a lot more comfortable, like, so that as long as you know this process and you can show this step by step, you should be able to actually get through this question without any hiccups. But you just got to go back and just go and practice this kind of whole thing again and again. All right, so the next part is use the information after a minute. This is really weird. So we've done this part. So the second part is just substituting t equals to 60, guys. So in this case, second part, you're just going... But before we do that, we've actually got to figure out what the k value is, right? So to figure out the k value, what we know is this. We know that t is equal to 60 and x is equal to 250 because it says half the sugar has dissolved after 60 seconds. So we're going to use this information to actually figure out what k is. So we're going to go back to our equation here. We know that t is equal to 60 and x is equal to 250. So this is part B right now. So we're going to get 500 minus 500 e negative k times 60 equals 250. So once you do that, rearrange it. So you're going to get negative 500 e negative 60k equals 250 minus 500, which is negative 250, and negative 500. So e of negative 60k equals negative 250 divided by negative 500, and e of negative 60k equals 0.5. Take ln of both sides, so negative 60k equals ln of 0.5, and k equals ln of 0.5 divided by negative 60. Okay, so once we get the k value, we've actually got the specific equation. Our specific equation is 500 minus 500 e to the power of negative. Now the kt, you could leave it in this format if you want, or you could actually work it out. It doesn't really matter. So what I'm going to do is we can actually work it out. What is ln of 0.5 divided by negative 60? So that's what it is. I mean, you could actually just write that down if you want. We got negative 0.0116 t. So that becomes our almost like, what do you call it? Specific solution, right? So finally, the question C asks, how long will Samantha have to wait before 495? So they actually tell you x equals to 495. So we're going to go into C. We're looking for x equals 495. And what is t? So this is what original x equation is. So we're going to put 500 minus 500 e to the power of negative 0.0116 t equals 495. So at this point, we're simply going to just rearrange and solve. Now, if you're feeling lazy, well, I wouldn't call it being lazy, but I mean, you do know that you've got your calculator just to kind of go through and check whether your answer is correct. So you could always do that just to see if your answer is correct, because and then show the working anyway. So what do we got? E to the power of negative 0.0116 x, and that's equal to 495. Click on solve. So x should be 396.99. Well, let's actually see if I can actually get it. So what was the answer? 396.99. So rearranging this, I've got minus 500 e to the power of negative 0.0116 t equals negative 5. 116 t equals negative 5 over negative 500. 0.1, is it? Oh, God. I blame it on the strong medication. So then I get negative 0.116 t equals ln of 0.01, and t equals, something is not right here. I'm sure I've done something wrong somewhere. I don't know where. We'll figure it out. Divided by negative 0.00116. Too many zeros. Close enough. There we go. So 396.99 is what you get, which is what we actually did before as well. Yeah, as these guys were saying, FBI, the formula sheet is your friend. It has a lot of your formulas that you actually need. It's there. Yeah, you're right. And I think this is why using Solver to actually go through your answer to just check that whether you're on the right track is always a good idea. Cool. So that would have been an excellence question, by the way. The working that I did for the last bit is definitely excellence. Mithila, I'll come back to it. I think I've got like a couple of other questions that I need to go through first, and then we'll get back to it, all right? Still got time. Having a look at this question, somebody did send this to me, so I'm going to kind of go through it real quickly. Nishit, nah, not really, mate. You'll be all right getting away with even if you have like rounding errors. So here is a merit question coming up, Leo. So in this question, they're asking, find the coordinates of the curve where the tangent is actually horizontal. Now, horizontal basically means, it means this, that it's a flat line, which means the gradient is equal to 0. All right. So what you have to do is you got to work out dy dx in this case, and then put it equal to 0. So because it's parametric equation, we got dx dt, which is 2t, dy dt, which is 3t squared minus 4. This is differentiation 1, Noor. So once we have this, then we can actually write down dy dx equals dy dt multiplied by dt dx which actually gives us 3t squared minus 4 times 1 over 2t. So we could rewrite this as 3t squared minus 4 over 2t. So at this point, we just need to now prove that the gradient is equal to 0, because if the gradient is 0, then the tangent will be flat. So we're going to put this equal to 0, and we're going to get 3t squared minus 4 over 2t. Cross multiply, 2t disappears. We're going to get 3t squared minus 4 equals to 0. Rearrange, 3t squared equals positive 4, and t squared equals 4 over 3, or t equals 4 over 3 plus or minus. Now, the part that's important is, if you go back to the question, it actually says find the coordinates. Coordinates with a little s. Alright, so that actually gives you the clue that there's actually 2 points, possibly 2 points. And we kind of know that because we've actually got 2 values for t. Our first value for t is positive 4/3, and our second value for t is minus 4/3. But we actually need to figure out what the x and y value is. So if you look at it, you got x is t squared plus 1, and y is t cubed minus, what is it? T cubed minus 4t. Salty, the 2t gets multiplied by 0, and so it becomes 0. Because remember, if I take the 2t across and I multiply it with 0, it's going to be 0. Horizontal means that the gradient is equal to 0. So the slope is like a flat line. Cool. So we still haven't found the coordinates. All we found was for what values of t is the gradient 0. So our first point, our x value is going to be 4 over 3 squared plus 1, comma, the y value is 4 over 3 to the power of 3 minus 4 times. So that's the first coordinate, where this is the x value, and this is the y value. So now we got to repeat the step for negative 4 over 3. So I'm just being lazy. I'm just going to write this as it is. But what I'm doing is I'm actually putting in the substituting the values in there. So that's my second coordinate. How do you know that x equals t squared plus 1? I think that it says right at the top of the question that they're actually telling us what x and y are. So once we actually get our t values, we're just substituting the t into x and y to actually figure it out. But we're using both, Salty. So if you look at the top line, this one is with positive, and then, sorry. So this one is with positive 4 over 3 substituted, and then this one is negative 4 over 3 substituted. All right, can we move on from this question? Are we happy with it? Bernie, where are you from, Bernie? Yeah, my voice is just killing me, man. New York. Ah, good of you to join us. How did you end up in this stream? All right, so we're going to move on to the next question. Zankor, it's a good question. To be honest, I think as long as you leave it as a coordinates, I think you should be all right. So I don't see any issues with you leaving your answer like that. They can't really penalize you for that because they asked you for the coordinates, you've given the coordinates. And for guys that are trying to get like excellence and stuff like that, they're not going to be sitting there punching that in the calculator. They're just going to show that they understand it. Huh. That's interesting, Bernie. I'm just wondering whether you probably caught something of. Okay, anyway, that's all right, man. Welcome anyway. It's always nice to have people from across the other side of the world joining us. Cool, man. All right, so this question here, what we've got is another merit question, and this is we're looking at product rule. All right, so straight away looking at this and separating it, so y is equal to x times e of negative x. We've got u and v, so u is equal to x, u dash equals to 1, v equals e of negative x, v dash equals negative e negative x. Where are you joining us from, Taylor? So we're going to differentiate this. So y dash equals u dash v plus uv dash. So we're going to get 1 times e to the power of negative x plus x times negative e to the power of negative x. Seattle. Oh, what is happening in the US? We're joining people. Nice, Taylor. Welcome from Seattle. All right. So we're trying to figure out the coordinates of the turning points. The important thing is we also got to find out the nature, which is a little bit annoying considering it's an exponential question, but yeah, apparently so, FBI. Anyway, let's just keep going because otherwise I'm never going to get done with this question. So what we've got is we're going to put them as 0 equals e of negative x plus x times, let's just get rid of the x, and we're going to write this as x e negative x. So at this point, I'm going to put down e negative x as a common factor, and I'm going to get 1 minus x. So at this point, what you can see is, I think somebody else asked me this question earlier. You know how you have e of negative x equals to 0, or 1 minus x equals to 0. Now this, not possible. So we're going to write down x is equal to 1. So what we've just discovered is the x value of the turning point. Sorry, I just got distracted by the chat that's happening. I should really focus on this, but so we've got for the coordinate, and again they actually say coordinates, and in this case we can see that there's only one coordinate where x equals to 1. So what we're going to do is we're going to substitute to find out what the value of y is. So remember that f of x is x e negative x. So then f of 1 is going to be 1 times e to the power of negative 1, which equals e to the power of negative 1. Now somebody asked me this before, can I actually leave as decimals? But in this case, the turning point, I'm going to leave it like this. When you expand, no, it's salty. It's actually times, it's actually getting x multiplied by negative e to the power of negative x. You're talking about here, right? So this one here, I'm actually multiplying it. It's not minus. Why 0.36 though? Vikesh, as long as you practice, you'll be alright, man. Well, FBI, in this case, when working it out, I could only find one coordinate. As I said to you, sometimes they just like to put a ruse. They like to mess with you, so they kind of mess around and just do stupid things like that. So Angie, yes, you do in this case, because that's the next step that I'm going to go through, which I'm surprised it actually came in as a merit question, because so with this one, what we have to do is we now have to differentiate it a second time. And because my function, because f dash of x equals e of negative x times 1 minus x, I'm going to use product rule again. But this time I'm going to use product rule like this. So u is equal to e of negative x, v is equal to 1 minus x. So u equals negative e of negative x dash, v dash equals negative 1. So I'm going to get f double dash of x equals u dash v plus uv dash, which means negative e negative x multiplied by 1 minus x plus u, which is e of negative x, times negative 1. Now, if I substitute 1 in there, then I'm going to get negative e negative 1, 1 minus 1, plus e to the power of negative 1 times negative 1. Blah, 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 blah. This is going to be 0, and this is going to be negative e to the power of negative 1. So, at this point, I need to figure out what this is. So negative e to the power of negative 1 is a negative number. So f double dash of 1 equals negative 0.367. And because of that, we can actually say the turning point 1e negative 1 is max, as f double dash of 1 is negative. That's my original equation. X. So what I've done for you guys is I've just quickly, I'm going to show you guys what the graph actually looks like. And you can see that, like when I actually plot this in Desmos, you can see that the curve ends up looking like this. And there is my point, which is 1.368, which shows me that this is a maximum point. All right. Sorry, I'm just going to go through quickly the chat just to see the questions. Why are you 12 worrying about this? I'll see you in 2 years, Sahaj Preet. So Angie, hopefully I can answer that question with the double differentiation. TS, if you get two values, then you still have to use double differentiation and substitute the x values for f double dash. All right. So say, for example, you end up with something here. In this case, you end up like x equals to 3 and 4. Then you got to work out what f double dash of 3 is, f double dash of 4 is. And then depending on which one is positive and negative, you actually say, you know, if it's negative, then that one is maximum. If it's positive, then the other one's minimum, and so on. See you in a year, Fred. Right. Let's see. All right. Okay. The old videos, 2014 relevant? Yes, they are, FBI. The 2014 one are just like skills which are still being used at the moment. All right, so I'll try Nishit because I still got that many questions to go before I come back to any of the other requests. I might, look, there's a couple of these questions I'm just going to kind of skip through because they're kind of repeats of the same one, particularly this one here. So find the coordinates where the normal is parallel to the line y equals -half. So to do this question, just remember that when it's like this, where the normal is parallel to the line, so the gradient in this case equals -half. All right. So it says you've got y equals 10x where the normal is parallel. So the gradient, how do I say this? You've got dy dx, which is going to equal sec squared x. Now it says it's actually the normal is parallel to this line. So whatever the gradient is, how do I explain this? You got to go backwards, all right? So if the normal gradient equals -half, which is going from there, then the actual gradient that you're going to be looking for is 1 over m, -1 over m. So you're going to get -1 over -half, which equals to +2. So here you just go 2 equals sec squared x, and you kind of just you kind of just work it out, rearrange, and you should be good to go. No probs, Elias. Good luck with your exams. This kind of, I think you guys are still doing your exams, right? Why does it not work? Why doesn't that work? TS, m is the gradient, right? We're kind of working backwards. So basically this this tan x, all right, it has a tangent where it's normal. So it's like you've got to convert the gradient. Zanko, we're just looking at the gradient value, all right? So we only look at the coefficient of x and we don't worry about the x. Because remember when you have like y equals -half x plus 0, this part here becomes the gradient, which is -half. And then I've got to flip it because that's the normal gradient. And so I've got to flip it. All right, guys, I'm just kind of keeping an eye on the clock as well. I'm going to do one last one, which is this one. The reason I want to do this one is because this keeps popping up again and again in exams, and it's just a good solid merit. It's a good solid merit question to kind of keep under your belt. YT Dan, level 1 exams are not important for uni, mate, so just make sure you can get into level 2 and level 3 calc. That's going to help you. Rami, are you talking about level 3? Yes, I'll be doing one more help desk in Sunday, I believe. We'll kind of spend a bit of time on Sunday. Alright, let's go through this one here, and then I'm going to call it a night, guys, because I got a pretty long day ahead tomorrow. Damn it, Krish, you're the second person to put that question up. Alright, fine, I'll do this one, and then the differentiation 2E from 2016, because you're the second person that's asked this question. Alright, so this question here, what we've got is, you just got to integrate this question, but the problem with this question is you could actually use substitution. Salty, salty, salty. Which question is that? Salty? From 2016? Just write it down, Salty. I'll do those last two questions and I'll be done. So what we're going to do is we got k to the power of k and 1, and we're going to put this as 4x minus 1 to the power of negative half dx equals to 6. Sky, ask one of these guys, they'll tell you. I'm just going to work through these questions first. Okay, so what we've got here is we can just do reverse chain rule real quickly. So we're going to write this as 4x minus 1, negative half plus 1, divided by negative half plus 1, and also multiplied by the differentiation of this, which happens to be 4. All right, now that's just doing this in like one shot. And now we've just gonna try and kind of clean this up. All right, so get rid of the two 4's, and we've got 4x minus 1 to the power of half divided by positive half, and that's between k and 1 equals to 6. Rearrange it, so we're going to get 2 times 4x minus 1 to the power of half, k and 1 equals to 6. So at this point, we just substitute it. So we've got 4k minus 1 to the power of half minus 2 times 4 times 1 minus 1 to the power of half equals 6. Get rid of the 2. So we can write this as 4k minus 1 to the power of half minus 3 to the power of half equals 6. Get rid of the 2. So we get 4k minus 1 to the power of half minus 3 to the power of half equals to 3. Rearrange, so we got 4k minus 1 to the power of half equals 3 plus 3 to the power of half. Square it, so we get 4k minus 1 equals 3 plus 3 to the power of half squared. 4k equals, so as you guys can see, I'm not really working it out, I'm just leaving things as is and just write my final answer as a fraction. Now at this point you can actually put this in, put it in a calculator and just get it out. Where was this question? 2E. Give me 1 second, guys. It takes a bit of time to actually sync up. E and E from complex numbers. Ugh, fun question. Okay, all right. Let's see. The question that I'm going to do 2e from from all right, let's see. Just waiting for it to sync up, guys. Give me a second. Oliver, I think I did that question a little bit earlier, mate. So go check it out. All right, guys. So we've got this question here, which is basically what we've been asked to figure out is maximizes the volume of the cone, right? So what we're going to need to do is we're going to need a couple of things. So the first thing we're going to need so the first thing we're going to need to do is we're going to need to go into our what do we call it? Our formula sheet to pick up the formula for volume of a cone. All right, because this actually says that we want to find volume of the cone. What's the maximum value of S so that the volume of the cone is maximum. All right, so we're going to go. Let's go to see if we can find formula sheet. Now, most of these volume questions that they do in calculus, they give you the formulas there. So we've got the volume of a cone. The volume of cone is 1/3 pi r squared h. Just going to take that down first. So that's the first thing. The next thing is this. Whatever the height is, so the distance from here to here is 6, and the distance from there to there is s. And because of that, the height of the cone is going to be 6 plus s. And then what we got? And then the next thing is, I want to put this as radius squared. So the radius, and I think this is the part where you guys need to be, just be patient a little bit, all right? So what you've got here is a circle. Now this circle's equation is x squared plus y squared equals to 6 squared. So if that's the case, then this point right here, we actually need to figure out what that point is. Because if you think about it, This distance from here to here is the radius of the cone. And if that's the radius, then this point right here could be set as S and R. Right? So in other words, what I'm doing is I'm replacing X and Y with S and R. So I'm going to write this as S squared plus R squared equals 36. Now, once I got that, the next step is I'm going to go back to my volume equation, and I want to get rid of R and H. So my first thing is H is equal to 6 plus S. So that's pretty simple, because like all I'm going to do is I'm going to get rid of H and replace it with 6 plus S. The next thing is I need to get rid of R squared. Now remember, R squared can be rearranged here so that R squared equals 36 minus S squared. So I'm going to replace R squared with 36 minus S squared. So when I do that, I'm going to get volume equals 1/3 pi 36 minus S squared multiplied by 6 plus S. So whether we like it or not, we'll have to expand the numerator. So we're going to get volume is equal to pi over 3. 36 times 6, this gives us 216. Plus 36x minus 6s squared minus s cubed. So all I've done is I've just expanded the two brackets out, and I've got this. So at this point, I just need to differentiate this. dv ds is equal to, because pi over 3 is outside, let me just kind of simplify this first before I differentiate it. 260. I missed something here. I get a feeling I've missed something. There we go. I know where my mistake is. 36s. Thank you, Aiko. I thought something looked a bit odd. So when we differentiate this, we're going to still have pi over 3 as a constant, so I'm just going to leave it outside for now. I'm going to end up with 36 minus 12s minus 3s squared. So remember that the maximum happens when it equals to 0, so I can put 0 equals pi over 3, 36 minus 12s minus 3s squared, which means pi over 3 gets rid of it, so it's 0. So I've got 0 equals 36 minus 12s minus 3s squared. Take 3 as a common factor. I'm going to get 12 minus 4s minus s squared. But you know what? I want to take that negative out as a common factor. So I'm going to put it as negative 3, which means this will become negative 12 plus 4x plus s squared equals 0. So negative 3 disappears and I get 0 equals s squared. Where did I get the x from? Plus 4s minus 12. So 0 equals s plus 6, s minus 2. Therefore, s equals negative 6 or positive 2. Just have to say that s equals to 2, because you can't have a negative 6. So the question says find the value of s which maximizes the volume of the cone, which we've done. Marti. Okay. Alright guys, so last question for the night, which is this one here. I believe this was 2016, 2E complex. Okay, so this question here, what we have is find the value of k so that it equals equal roots. So this is basically telling you that get it into a quadratic and use discriminant. That's what you got to do. So to get this into a quadratic, we're going to do 8 minus 2x plus k equals to 0. I'm going to get rid of the x minus 8 to the other side. And this is something that's worth knowing, guys, is how to get rid of the square root. And like a lot of people make mistakes. Equal roots means discriminant is equal to 0. So remember this thing, 2 roots, no root, 1 root. So this is like equal roots, perfect square. Those are the kind of language they tend to use for one solution. So equal roots basically means 2 same answers. Sorry, my bad, thank you for that. X minus 8. So now what we're going to do is we're going to square everything, which means we're going to square this and square this. And be very careful when you guys do this. So 2 squared becomes 4, multiplied by 2x plus k equals this one. Make sure you do x squared, the full brackets, because a lot of people just write this as x squared minus 64 and forget the 16x. So remember, you got minus 16x plus 64. So what we have is 8x plus 4k equals x squared minus 16x plus 64. Rearrange. X squared minus 16x minus 8x plus 64 plus 4k minus 4k. So we have 0 equals x squared minus 24x plus 64 minus 4k. So at this point, because they're asking for one solution, b squared minus 4ac is equal to 0. Our b value is there, our a value is there, and our c value happens to be there. So negative 24 squared minus 4 times 1 times 64 minus 4k equals to 0. Expanding it, we got 576 minus 256 plus 16k equals to 0. So you get 320 plus 16k equals to 0. So 16k equals minus 320, and k equals minus 320 divided by 16, which gives you negative 20. Yep, that's pretty much how you guys do this, how you do this question, guys. And I think that's me done for the night. So by the way, this question was an excellence question, but it's just a matter of just rearranging the equations and putting everything together, that's all. So keep practicing. So Salty, you're actually talking about quadratic equation there. So in this case, we're actually using discriminant and not quadratic equation. Yep, Nishit, I'll start putting the. So basically, what I do is I'll put up another page, and I'll start loading questions there, and you should be able to see a question there. Yes, Krish, this will be uploaded the moment I stop this video. It should get uploaded pretty much straight away, so you can watch it. Yeah, sure, no worries, Nijit. I'll have a look at it. All right, guys, look, that's basically it from me. I need to take a break, and I will catch you guys on Sunday. Till then, just keep practicing those papers. Yeah, and I think I've got a few questions up there for revision, but like always, yeah, go back and just practice questions. That's the best thing I can tell you. Cool. I gotta get going. I need some water. Long day tomorrow. Looking forward to the parent-teacher meetings. All right, guys. Thank you for coming. We'll see you on Sunday for the final tutorial for you guys. See you later.